Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today, for exam P on probability. A motorist just had an accident. The accident is minor with probability 0.75 and is otherwise major. Let B be a positive constant. If the accident is minor, then the loss amount follows a uniform distribution on the interval from 0 to B. If the accident is major, then the loss amount follows a uniform distribution on the interval B to 3B. The median loss amount due to this accident is 672. Calculate the mean loss amount due to this accident. And here's a solution. Let us write x for the random amount of the loss, x1 for the random amount of a minor loss, and x2 for the random amount of a major loss. We know that x1 is uniform on 0b, x2 is uniform on b, 3b, and x is equal to x1 with probability 0.75 and x2 with probability 0.25. Of course, this is telling us that x is a mixed random variable, a mixture of x1 and x2. And note that x1 is less than x2 with probability 1, and therefore the median of x is the value m such that probability that x1 is less than m is equal to 1/2 as a fraction of 0.75, which is the probability with which x1 happens. So x1 has the smaller values. So if you go with probability from 0 to half, you don't even go to kind of the end of x1. And it is the end of x1 because x1 is always below x2. So values of x1 happen kind of first and then x2. And so we reach probability of half within x1 in a sense. And it's 0.5 divided by 0.75. That's the fraction that the value takes up. Now it's half probability for x, but for x1 it's half as a fraction of 0.75, so it's 2/3. And that means that 672, which is the median, is 2/3 of b, because x1 is uniform from 0 to b, and so you reach the probability of 2/3 at 2/3 b, and that means that b is equal to 1008. Hence, x1 is uniform on 0 to 1008, x2 is uniform on 1008 to 3 times that, which is 3024. And remember, for uniform distribution, the midpoint of the interval where that uniform, one-dimensional uniform, has positive density is the mean. So the midpoint of 0 to 1008, which is 504, is the mean of x1, and the midpoint of 1008 to 3024, which is 2016, is the mean of x2. Also, for a mixed distribution, the moments of the mixed random variable are weighted averages of the moments of the components random variables in this case, and of course the weights are the probabilities assigned to them. So it's e of x is equal to 0.75 e of x1 plus 0.25 e of x2, and that's 0.75 times 504 plus 0.25 times 2016, and that's 882, which is answer D. And this is a reminder that you need to know mixed distributions for exam P. This is very important. It's going to be on the test. Mixed distributions are important. They are very important in insurance applications. That's why you'll get questions about them. And of course, they're covered wonderfully in my Exam P manual, so that's what you should study. And if you haven't studied it, mixed distributions in your probability class, you should get your money back for your probability class because it wasn't worth it. So please remember you need to know mixed distributions. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.